Hello friends, this is Ganesh. Please watch my previous videos. Link has been provided in the description. In this video, we are going to see Hive bucketing. Let us consider we have a bucket full of 120 items of 6 products. We need to move 4 products into these 4 buckets with each having few samples of 4 products. Taking samples from a single bucket will take time because we need to first segregate the products from the single bucket. Instead, consider we have all the products already got segregated. Then taking samples out of each bucket will become easier. In the same way, if we need to count few products which is available in a single bucket with already having some 4 buckets with few products available. If we need to take count of products from a single bucket, in the same way we need to segregate and then we need to count. If we have all the items segregated, then we need to count only the items in the respective blue bucket and the respective blue bucket here. This is what we are going to do in Hive bucketing. We'll see when we need to use bucketing, why and how. Bucket tables could be more efficient in sampling than non-bucketed tables. It will improve performance when we use map side joins. When we have large unique values in a column, instead of doing partition we could use bucketing, because if we have large unique columns it will create more partitions. In the same way, if we use sort by columns it will make join query faster. Each bucket will be created as a file, but in partition it will be folders. Bucket numbers are determined by using the expression has function of bucketing column mod number of buckets. In partition we need to use high cardinal columns, but in bucketing we could use both high and low cardinal columns. We could create bucketing in partition table also. To create a bucketed table and load the bucket table, first we need to set the dynamic property true and partition mode as non-strict. Then we are creating the table store sales underscore bucket with the cluster by class having state and sorted by city into 10 buckets. Then we are loading the table created from the store info table which we have created already. This is the process happening while we load the bucketed table. It shows we have one mapper and 10 reducers. 10 reducers, due to we have 10 buckets, we could see we have 10 files 0 to 9 got created in the location of the bucket table store sales underscore bucket. Each file represents one bucket, each bucket having different size. It is based on the hash value of the column which we have provided. We could do sampling on the bucketized table. The class a table sample will allow user to write queries for samples of data instead of whole table, but it will scan the entire table and fetch the sample. It will be inefficient. Instead, that we could create a cluster by class which indicates the set of columns on which the table is hash partitioned or clustered. If the column specified in the table sample class matches the column in the clustered by class, table sample scans only the required hash partitions of the table. Here we are executing a query on the bucket table sales store sales bucket with a table sample of bucket 5 out of 10 on the column state. State is the column which we have bucketed. So it would pick the fifth cluster, as each bucket would be composed of only one cluster, because we have mentioned bucket 5 out of 10. So it will be the first one will be the number of buckets, and it is the value which we have mentioned in the table sample. In the same way, if we provide a query of table sample bucket 2 out of 5 on state, then it would pick out the second and 12th clusters, as each bucket would be composed of 2 clusters. It means total 10 buckets, and as per the same sampling we provide 5. So we will have 2 clusters in each bucket. We are taking second and 12th clusters as the output. That's all for the video. Please share the channel and subscribe the channel. Thank you. Have a good day.